Alright, let's go. Number 10. The null hypothesis. In 1714, philosopher Gottfried Wilhelm Leibniz posed what many consider the most fundamental question in all of human thought. Why is there something rather than nothing? 3 centuries later, we still don't have an answer, but some physicists have proposed something even more disturbing than the question itself. Nothing might be impossible. The concept of absolute nothing. No space, no time, no energy, no laws of physics, no mathematical framework may be inherently unstable. Philosopher and physicist David Albert argues that true nothingness is a state so devoid of structure that it lacks even the rules required to maintain itself. Without laws to enforce its own emptiness, nothing cannot persist. It collapses under the weight of its own absence. What makes this theory particularly unsettling is its implication about existence. If nothingness is unstable, then something must always exist. The universe didn't emerge from nothing because nothing was never an option. Reality isn't a gift or an accident, it's a requirement, a mathematical inevitability written into the fabric of logic itself. Before time, before space, before energy, there was no peaceful void waiting to be filled. There was an impossibility demanding resolution. We exist because non-existence was never permitted. The truly disturbing aspect is what this means for endings. If nothing cannot exist, then the universe in some form must persist forever. Not because it's special, but because the alternative is logically forbidden. There is no off switch. There never was. Number 9. The quantum foam epoch. In 1955, physicist John Wheeler proposed that at scales smaller than anything we can observe, roughly 10 to the negative 35 meters, space itself isn't smooth, it boils. Wheeler called this quantum foam, a churning sea of virtual particles appearing and vanishing, in duration so brief they make a femtosecond look like an eternity. Each fluctuation creates and destroys miniature geometries of spacetime, tiny bubbles of reality forming and collapsing trillions of times per second. Before the Big Bang, if the word before even applies, this foam may have been all that existed. No structured universe, no coherent time, no stable matter, just an eternal frothing of quantum probability, a sea of potential realities endlessly generating and consuming themselves. Occasionally, one of these fluctuations doesn't collapse, it inflates. It becomes a universe. The mathematics are grounded in quantum field theory, and they suggest our entire cosmos might be the result of one such fluctuation that grew instead of dying. A quantum hiccup that expanded into 2 trillion galaxies. The foam itself didn't begin. It doesn't need a cause because causality requires time, and time is a property of the bubbles, not the foam. The foam simply is, has always been, and will always be, generating universes the way a boiling ocean generates steam. Each bubble a cosmos, each cosmos temporary. What makes this scenario particularly chilling is the implication about our significance. We are one bubble in an infinite froth. Our entire observable universe, every galaxy, every star, every civilization that has ever existed or will ever exist, is a momentary fluctuation in a medium that doesn't notice or care that we formed. When our bubble eventually pops, the foam continues, unchanged and indifferent, generating new realities to replace us without registering that we were ever here. Number 8. Conformal, cyclic cosmology. On October 5, 2010, Nobel Prize-winning physicist Roger Penrose published a paper with Vahe Gurzadian claiming they had found evidence of a universe that existed before our own. The evidence lay in concentric ring patterns in the cosmic microwave background radiation, the ancient afterglow of the Big Bang. These patterns, Penrose argued, were gravitational echoes of supermassive black hole collisions from a previous cosmic era, imprinted on the birth of our universe like bruises from a past life. Penrose's conformal cyclic cosmology proposes that the universe doesn't begin and end once. It cycles. When a universe reaches maximum expansion and all matter decays into radiation, something extraordinary happens. A cosmos containing only massless particles loses any meaningful distinction between enormous and infinitesimal scales. The infinitely large, empty, cold end state becomes geometrically identical to the infinitely small, hot, dense conditions of a new Big Bang. Death becomes birth. The end of one universe is indistinguishable from the beginning of the next. Before our time, there was another universe's time. Before that, another. Each era, which Penrose calls an aeon, gives rise to the next through a mathematical transformation that resets scale but preserves certain information. The rings in the cosmic microwave background aren't noise. They're messages from a dead cosmos, gravitational scars that survived the transition between aeons. We've been reading the sky for decades without realizing we were looking at the autopsy report of a universe that died so ours could be born. The truly nightmarish implication is the infinite regression. There was no first universe, no original beginning. The chain of aeons extends backward without limit. Every universe is both an ending and a beginning, and the question of what came before time has no answer because there is no before. Just an endless chain of dying and rebirthing realities, each one built on the corpse of the last. stretching back through a sequence that never started because it was always already happening. Number 7. The cosmological natural selection hypothesis. In 1992, theoretical physicist Lee Smolin proposed a theory that applies Darwinian evolution to universes themselves. Every time a black hole forms in our universe, it creates a new baby universe on the other side of the singularity. This offspring universe inherits the physical constants of its parent, but with slight random mutations. The laws of physics evolve. Before our time existed a parent universe. Before that parent, a grandparent. Each generation of cosmos is slightly different from the last. Its fundamental constants shifted by small, random variations during the black hole birth process. Universes that produce many black holes generate many offspring. Universes with physical constants hostile to black hole formation produce few or none over countless generations. The multiverse naturally selects for universes optimized to create black holes. Here's where it becomes deeply unsettling. Our universe is extraordinarily good at producing black holes. The stellar masses, the gravitational constant, the nuclear forces, all appear fine-tuned not for life, but for the maximum production of gravitational collapse. Life might be a side effect. Consciousness an accident of optimization for an entirely different purpose. We exist not because the universe was designed for us, but because the constants that maximize black hole production happen to also permit stars, planets, and chemistry complex enough for biology. What makes this theory particularly disturbing is its implication about purpose. Every star that will ever collapse into a black hole is reproducing the universe. Every supernova is a cosmic birth event. The universe isn't indifferent to us. It doesn't even know we're here. It's busy reproducing through gravitational collapse, and we're an unintended consequence of the physics required for that reproduction. Before our time, there was a universe whose only legacy was the black hole that birthed us. Our parent cosmos didn't create us out of intention or design. It created us the way a forest fire creates ash. We are the accidental children of a dead cosmos that existed only to make more of itself. Number 6. The ekpyrotic scenario. In 2001, physicists Paul Steinhardt and Neil Turok proposed a model that replaced the Big Bang with something far stranger. Our universe exists on a three-dimensional membrane, a brain floating in a higher dimensional space called the bulk, parallel to our brain. Separated by a gap smaller than an atom in the extra dimension, another brain floats, another universe. Invisible and unreachable, but close enough to touch. Before our time began, these two brains drifted toward each other through the bulk. The approach took an unimaginable duration, not measurable in our time because our time didn't exist yet. When the brains finally collided, the kinetic energy of impact converted into the matter, radiation, and energy we observe today. The Big Bang wasn't an explosion from nothing. It was a collision between universes. The physics are grounded in string theory and M-theory, frameworks that require extra spatial dimensions beyond the three we perceive. The bulk, this higher dimensional arena, has always existed. The brains move through it like sheets of paper drifting in water, occasionally touching, each contact generating a new Big Bang on one or both surfaces. Our universe is the aftermath of one such contact. Before our time, there was the slow, silent approach of two membranes through a dimension we cannot access or observe. The most chilling aspect of the ekpyrotic scenario is its inevitability. The brains will drift apart after collision, slow down, stop, and begin approaching again. Another collision is coming. Another Big Bang will overwrite everything in our universe, every galaxy, every planet, every record of our existence, replaced by a new cosmos generated from the next impact. Before our time, there was a universe just like ours. It was erased completely when the collision that created us occurred. Everything that universe ever produced, every star it lit, every form of life it may have harbored, was annihilated in the instant we were born. We are living in the interval between destructions. Number 5. The mathematical universe hypothesis. In 2007, physicist Max Tegmark at MIT proposed something that challenges the very nature of existence. The universe isn't just described by mathematics. The universe is mathematics. Physical reality is a mathematical structure, and every consistent mathematical structure exists as a physical reality somewhere. Before time existed, mathematics existed, not as an invention of minds, but as the fundamental substrate of all possible realities. In Tegmark's framework, asking what came before time is like asking what exists outside a particular equation. The equation doesn't have an outside. It simply is, complete and self-contained. Our universe is one mathematical structure among infinitely many, each one as real as ours, each one containing its own version of space, time, and physical law. Some contain conscious observers. Most don't. We find ourselves in one that does, not because it was designed for us, but because we can only exist in structures complex enough to generate awareness. What makes this theory particularly unsettling is its implications for existence itself. You are not made of atoms. You are made of mathematics. Your consciousness is a pattern. a self-aware equation embedded in a larger mathematical structure that neither began nor will end. Before time, there was no void, no darkness, no empty space waiting to be filled. There was the timeless, changeless existence of every possible mathematical object, each one a reality unto itself, none of them created, none of them capable of being destroyed. The truly disturbing conclusion is that this framework eliminates all meaning from the question of origins. Nothing created the universe because the universe was never created. It exists the way the number 7 exists, not because someone invented it, but because its non-existence is a logical impossibility. Before time, there was the eternal fact of mathematics, and somewhere in that infinite library of abstract structures, the equation that describes your life has always been written. You didn't begin. You were always there, waiting to be read. Number 4, the Big Bounce. In 2006, physicist Abhay Ashtekar applied a framework called loop quantum gravity to the conditions of the Big Bang and discovered something that contradicted decades of cosmological assumption: the singularity. That point of infinite density where physics breaks down and time supposedly begins doesn't exist. Instead, the equations revealed a bounce. Our expanding universe was preceded by a contracting one that collapsed to an extraordinarily dense but finite state and then rebounded outward. Before our time, there was time. Another universe's time, running in the opposite thermodynamic direction, contracting where ours expands, cooling where ours heated, the atoms in your body, the light from distant stars, the cosmic microwave background radiation, all of it is recycled material from a previous cosmos that collapsed under its own gravity and bounced back into existence as our Big Bang. Nothing was created. Everything was transformed. The physics are grounded in loop quantum gravity, which quantizes space-time itself into discrete units at the Planck scale. At extreme densities, this granular structure of space generates a repulsive force that prevents complete collapse. The universe cannot crush itself to zero volume. It reaches a minimum, then explodes outward again. The Big Bang becomes the Big Bounce, and the question of what existed before time receives a concrete answer: another universe, contracting, aging, dying, and then being reborn as ours. What makes the Big Bounce particularly disturbing is the question of information. Did anything survive the transition? The mathematics suggests that most structural information is destroyed during the bounce. The compressed state scrambles nearly everything, but certain quantum signatures might persist, ghost patterns from the previous universe embedded in the fundamental structure of our own. We might be living in a cosmos haunted by the faint imprint of a dead reality, carrying scars from a universe we can never reconstruct, never study, and never understand. Our past extends beyond our beginning, and we have no way to read it. Number 3, the eternal inflation multiverse. In 1983, physicist Andre Linde proposed a modification to Alan Guth's inflation theory that transformed our understanding of cosmic origins. Inflation, the exponential expansion of space in the universe's first fraction of a second, doesn't stop everywhere at once. In most of space, inflation continues forever. Only in isolated pockets does it end, and each pocket becomes a universe with its own physical constants, its own dimensions, its own version of time. Before our time, there was inflation, not an event with a beginning, but a process without one. Eternal inflation has always been occurring, generating an infinite number of pocket universes embedded in an ever-expanding inflating space. Our Big Bang wasn't the beginning of everything. It was the local end of inflation in our particular pocket, the moment our region of space stopped expanding exponentially and started cooling into matter and radiation. Elsewhere, inflation continues this instant, spawning new universes at a rate that renders counting meaningless. The mathematics are supported by multiple independent frameworks in theoretical physics. The inflating space expands so quickly that it always produces more volume than pocket universes consume. For every universe that nucleates, the surrounding inflationary space has already expanded enough to generate countless more. The process is self-sustaining, self-amplifying, eternal in both temporal directions. The most terrifying implication is the absolute erasure of origin. There is no first universe, no initial condition, no moment of creation. The multiverse has always existed in a state of perpetual self-generation, and our cosmos is one of infinitely many bubbles in a froth that has no beginning, no edge, and no architect. Before time, there was more time. Before that, more still. The regression never terminates because there is nothing for it to terminate against. We are asking for the starting line of a race that was always already underway. The question of what came before has no answer, not because we lack the tools to find it, because the answer doesn't exist. Number 2, the holographic pre-universe. In 2013, a team of physicists at the Perimeter Institute, led by Niyai F. Shorty, proposed that our universe emerged from the collapse of a star in a higher dimensional cosmos. Not a three-dimensional star like those in our sky, but a four-dimensional star in a four-dimensional universe that collapsed into a four-dimensional black hole. The event horizon of that black hole, a three-dimensional surface wrapped around the singularity, is our universe. Everything we experience, every galaxy, every particle, every second of time, exists on the boundary of a black hole in a reality with more dimensions than we can perceive. Before our time, there was a four-dimensional universe with its own physics, its own stars, and its own history. One of those stars exhausted its fuel and collapsed. The resulting black hole created a three-dimensional event horizon, and on that horizon, a holographic universe sprang into existence. Ours. We are a projection, a lower dimensional echo of a catastrophic event in a higher dimensional reality we cannot access or observe. The physics are grounded in the holographic principle first proposed by Gerard de Hooft in 1993 and refined by Leonard Susskind. The principle states that all the information contained within a volume of space can be encoded on its boundary. Our three-dimensional universe could be a holographic projection of information stored on a two-dimensional surface, or in this case, the three-dimensional event horizon of a four-dimensional black hole. The mathematics are consistent with observed cosmological data, which makes the theory impossible to dismiss as pure speculation. What makes this theory particularly disturbing is the dependency it creates. Our universe exists because a star died in another reality. If that higher dimensional black hole evaporates through Hawking radiation, the event horizon shrinks. If the event horizon shrinks, our universe contracts. Our fate is determined by physics operating in a dimension we cannot observe, governed by laws we cannot study, in a cosmos we cannot prove exists. We have no way to monitor the health of the black hole we inhabit, no way to predict when evaporation might begin to compress our reality. Before time, there was a dying star in a world with more dimensions than ours. We are the shadow it cast as it collapsed, and shadows disappear when the object casting them ceases to exist. Number 1. The timeless everything. In 1967, physicists John Wheeler and Bryce DeWitt derived an equation that unified quantum mechanics and general relativity at the cosmological scale. The Wheeler-DeWitt equation describes the quantum state of the entire universe. But when they solved it, they discovered something deeply wrong. The equation contains no time variable. Time doesn't appear in the fundamental equation governing reality. It isn't a feature of the universe at the deepest level. It's an emergent illusion, a useful approximation that conscious beings construct for more fundamental timeless processes. Before time existed, everything existed. Not sequentially, not in order, not unfolding from past to future, but simultaneously. The Wheeler-DeWitt equation describes a universe where all configurations of matter and energy exist in a single timeless superposition. Every possible arrangement of every particle, every moment you've experienced, and every moment you haven't, all of it exists in a frozen, eternal mathematical structure where nothing moves, because movement requires time, and time isn't real. Physicist Julian Barber expanded this into a framework he calls Platonia, a timeless landscape where every possible configuration of the universe exists as a single point. What we experience as the flow of time is our consciousness tracing a path through this landscape, moving through static configurations and interpreting the sequence as change. But the landscape itself doesn't change. It doesn't need to. Every moment that will ever exist already does. The birth of every star, the death of every civilization, the last thought of every conscious being that will ever live, all of it is already present in the structure, waiting to be experienced but never actually occurring for the first time. What makes this theory uniquely terrifying is what it means for death, suffering, and every moment of human agony ever experienced. If time is an illusion and all moments exist simultaneously, then nothing ever ends. Every instant of pain that has ever been felt still exists in the timeless structure of reality. Every death is still happening. Every moment of fear, every loss, every extinction event in the history of every civilization across every planet in the observable universe, all of it is permanently embedded in a frozen eternal now that never passes and never resolves. The truly nightmarish implication extends beyond Earth. If the timeless everything is real, then every possible configuration of matter exists. This includes configurations that encode conscious suffering in every conceivable form. Not just human suffering, but alien suffering, artificial suffering, forms of awareness and torment that we lack the cognitive architecture to even imagine. All of it exists. All of it is permanent. And the word before becomes meaningless because there is no before. There is no after. There is only the eternal structure of all possible realities, frozen and complete, containing every joy and every horror in equal measure. None of it chosen, none of it escapable, all of it simply and permanently real. If you want to see more videos like this, click the video on screen now and make sure to subscribe.